Welcome to the Fedora Podcast, a proud member of the Destination Linux Network, Season 2, Episode 4. This is the podcast to teach you about how the Fedora community works. We bring you news, interviews, and more. I am Edward, and today we have the part 2 of the interview with Chris Murphy.
Hey, I'm Grayson, back with Chris Murphy. Let's kick off the interview. Newly enabled in Fedora 34 is BTRFS transparent compression, which translates to you write the file, it's automatically smaller, being compressed by your CPU before it even hits the disk. What is it? Could you explain that to me?
Yeah, so BTRFS has had the ability to do transparent compression since almost day one, back in 2008. It was using zlib. Soon thereafter, LZO algorithm was added. And almost at the exact same time, Grub started supporting all these compression types with BTRFS. So it was able to still boot BTRFS when compressed. So that was kind of cool how quickly all that came together and how, it just worked. It was nice. So the latest addition in BTRFS for compression is zstd, contributed by Facebook folks, or zstd, Z standard. And that's what we're using by default in Fedora 34 for the entire file system. So when the operating system is installed, it is compressed, and there is an fstab option, mount option, that indicates that we're using compression zstd. And there's also a level number after it. So the zstd supports a number of levels as to how aggressive, how much CPU it's willing to use in order to do the compression. And we're using level 1, which is the least amount of CPU. So it's also the least amount of compression. So what you end up with is it pretty much compresses low-hanging fruit. So anything that's easy to compress, it compresses. Anything that's marginal, it's not as beneficial, especially if it's already compressed. Those things it skips over. It doesn't even try to compress them. There's an intelligent heuristic that is able to cheaply estimate whether or not compression is even worth it. And if it decides it's not worth it, it doesn't do it. That heuristic is fairly conservative. So it does tend to leave more compression potential on the table. But the main idea is not to do the best possible job, but to do the most compatible job, because we don't want to slow people's machines down. At worst, we want it to be pretty much the same. If not, in some cases, we're able to go a little bit faster with slower storage devices like hard drives. And the reason why is because the less you have to write and the less you have to read, the less I/O you're doing. So on slower devices, SD cards, again, hard drives, anything like that, the tendency is that you see a little bit of a speed improvement. It's modest. It's not like it's a massive speed boost, but it's generally better than it is worse. And if it's worse, then I would say it's probably a bug and we ought to look at it. I haven't seen that myself, but there are, in theory, there are some cases where that could come up. With the advent of NVMe drives, they're so fast that it is, possible that there's some, really hitting write-heavy workload that may be better off disabling compression. But the vast majority of folks probably won't notice it, except they have more space available.
Can I just say, I'm so happy that you called it fstab, because I call it that too. And I know that it's supposed to be fstab, or fstab, but I always think it's fstab.
I say fstab all the time. I see there's so many things that I say wrong. It's kind of funny. Yeah, you're right, fstab.
How much space can the average user expect to save? Like if they're just me on a laptop with a 500 gigabyte SSD, how much can they expect that they'll have extra?
That's a good question. It's going to really depend on what file types you have on your system. A new clean install of Fedora 34, it's roughly 45% less storage requirement. So that would be consistent for everybody. Where it's going to change is what packages you add to the default installation, what kinds of files you have in home, that sort of thing. So in my case, it's hovering, I think, right around 70%, of the original size of uncompressed size. So I'm saving 30%, give or take. But it's highly variable. It just depends on some of the files, like text files. I write lots of text files and documents and things like that, and those are highly compressible. Those are maybe 90% compressible. So their size ends up being maybe 10% or 5% of the original size. So there's huge gains on files like that. And yeah, other files, they don't compress quite as much.
That is insane. That is so exciting. Is there a quick, easy way I can check this out of curiosity?
So what we've included by default in Fedora 34 along with this feature is the program comp size, COMPSIZE comp size. So all you do is sudo comp size and point to a file or directory, and it'll give you some stats on compression. It'll tell you what portion is compressed, how much it's compressed, what algorithm is used. It'll give you quite a decent amount of. It's not a whole lot of results returned, but it's worthwhile reading the man page to get all the nuggets, all the special terminology nuggets, because it's a little bit full of terminology. So eventually, what I expect is that we'll get something like comp size features in the BTRFS tools directly. Maybe it'll go in BTRFS file system DU, or at some point it might be that somebody decides to do the work on addressing some of these questions in DU, just plain ordinary DU.
That is awesome. I am definitely checking this after recording. I don't want to bog down my machine and make the fan spin up while we're recording, but that is super cool. This transparent compression is going to be introduced in Fedora 34, but BTRFS was introduced as the default in Fedora 33. How come we waited for the compression?
That's a good question too. Yeah, because we did actually have compression as one of the optional feature items in the original Fedora 33 feature change set, along with a couple of other things. The main reason, honestly, that it didn't get rolled in is we ran out of time. There were so many other things that were getting jammed into Fedora 33. Tons of features, more than any previous Fedora, and I think the stat now on Fedora 34 is that it superseded Fedora 33. So we've got back-to-back chock full features in both the two recent Fedoras. And that's really what it came down to, is we just ran out of time to get it all done. So there were a few little tricks that we needed help from the Anaconda team on to enable it in Fedora 34. So that got done. And that was basically it. Compression's been something that's supported in the kernel for BTRFS, like I said earlier, for quite a long time. So that wasn't a concern. The stability is not a concern. Yeah, it's good to go. And yeah, there's not a problem if people want to disable it. If you have a particular use case, you're concerned about performance, benchmark it and see. And there's not any difficulty with just removing the option from FS tab, or like I like to say, by habit F tab. Yeah, so folks are welcome to make those kinds of customizations if they want. They're also welcome to change the levels if they want to as well. I don't. I use the defaults. I use pretty much all the defaults. I don't really change things a whole heck of a lot.
I think most people are going to be using the defaults, which is why I'm so excited that it's going to be in Fedora 34. That is so cool. If I was running Fedora 33 and I'm now upgraded to Fedora 34, will the compression be enabled for me, or do I have to do that manually?
Very good question. Yes, you do need to manually go in and enable it. And the way to do it is to edit FS tab and just add the compress equals zstd :1. So you just add that to FS tab. Strictly speaking, it only needs to be added to the root line. So it is not, it looks like in FS tab that it might be a per subvolume feature. It is not. It is a file system wide mount option. So everyone's got their own FS tab nomenclature. Where it needs to be set is on the root line. I tend to set it on all of them just for pretty columns mostly, and to make, remind myself that the entire file system is being compressed. So you do need to do that. It is an option to defragment the file system. You can defragment the file system and enable the switch C Z standard, zstd, and that will retroactively compress everything that's not already compressed. There's no requirement to do that. You don't have to do that step. It's completely legit to just change it in FS tab, and the next time you reboot or remount the root file system, it'll enable compression, and all new writes will be compressed. And over time, you'll just get space savings as your files are edited and as you do system updates and things like that. So, you don't have to get too aggressive if you don't want to and defrag the whole file system. It's not a requirement.
In the show notes, we're going to have a link to a Fedora magazine article where this all gets discussed. So please check that out if you want to do that.
So we have this feature that is for snapshots on BTRFS. So what is a snapshotting of BTRFS? We will have it in Fedora?
Yes, as a matter of fact, we already have it. You can manually do snapshots on your own just with the command line tools using BTRFS subvolume snapshot. But as far as automatic snapshots and rollbacks, that is something that we are going to have. I don't know when it's going to happen because it's actually a little bit complicated. So the snapshotting itself is very cheap and straightforward. Rollbacks are actually also relatively cheap and fairly straightforward. Where things get a little bit complicated is user interface. How do we indicate that these things need to happen? How does the user get involved? How is the user going to know that they need to do a rollback and how to do a rollback? And one of the stickiest areas that we've got right now is the bootloader. The bootloader menu is something that we really kind of want to get away from. And there have been a number of features, including flicker-free boot and hidden grub menu by default. So folks don't see a boot menu by default if things boot okay. If the boot fails for whatever reason and they reboot, then they do see a grub menu. So there's a little hidden feature that helps enable that functionality. So it gets a little bit tricky dealing with the interface for that sort of thing. We do know that what OpenSUSE is doing works. OpenSUSE has been doing snapshots and rollbacks, and you can see the snapshots in the grub menu, and you can choose one and boot it. It boots read-only, and you can verify whether or not the rollback worked. And if it did, then there's a GUI program, a graphical program that you can use to say, yeah, it worked. That's the snapshot that I want to roll back to. And then what it does behind the scenes is it does a snapshot of a snapshot. It actually makes a snapshot of the read-only snapshot that you're actually booted in and makes it a read-only snapshot. And then you reboot. Now you get a read-write, a normal, fully functioning read-write boot that is a rollback. So that we know that works. We know it's robust. We could use that. But it's Fedora. So Fedora is looking to see how it can push things a little bit farther, considering all the other work that we've been doing on the desktop. So that's the long answer to yes, we will have it. And hopefully everyone will be patient because it'll probably require some patience.
But if you don't want to be patient, how can you contribute to ButterFS and we can start moving toward getting this stuff done faster?
It's a really good question. The working group is really keen to incorporate and get more contributions from the community. So this is a really good area for, if nothing else, discussions of all of the expectations, the quandaries, the potential difficulties, and fleshing out what it is the community wants it to look like, and drive the direction of what it is that it will end up looking like.
My next question is, what do you see in the future for ButterFS and Fedora that we haven't mentioned yet?
Probably the biggest thing I'm looking forward to is some kind of snapshot and rollback. And the more straightforward and, out of the way that it is, I think the better. I'm not really stuck on how it ends up looking, but that's kind of what I would like to see, is something that's relatively lightweight. As far as other features that I know that are landing relatively soon that are interesting, there is a proposal that was made for Fedora 34, but it was pushed off to Fedora 35 because it wasn't quite ready yet. And that is RPM is going to have the ability to do ref links. So what will happen on ButterFS, and I think it's the same on XFS, but I'm not as privy to their implementation as I am with ButterFS. But what it is going to be able to do is, as the RPMs are being downloaded, they will be decompressed from their native RPM payload and saved just as a regular RPM on disk. But then instead of being unpacked like an RPM file where the whole thing is read and then all the files in the RPM are written elsewhere, what will happen is, on ButterFS at least, reflink files will be made. So what that means is that just the file inode and the location will be pointed to within the RPM. So the RPM will have this payload, this extent payload of its contents. And we'll use ButterFS ref links to just make the small metadata portion of the file pointing to the already written data that was done when the RPM was saved. So what this translates into is a lot of words, maybe not very, very elegantly stated, but what will end up happening, what the user will see, is quite significantly faster updates, because the files won't need to be unpacked and written out again. They'll already be written as they're downloaded, and then the update will go by really quite a lot faster. I don't have any benchmarking on that yet, but I would expect that it could be appreciably faster, especially for doing offline upgrades, because there's just so many RPMs that end up having to be unpacked and written out into a bunch of different locations. So system upgrades could get a good deal faster. It'll be very interesting to see how that turns out.
That's a super interesting concept. I hadn't even heard of that as an idea before. So when I'm normally DNF updating, I see it goes through and downloads all the packages, and then I believe it checksums them, and then it will go to the install phase, and it will do scriptlets, and it will write out the payload to its correct location. Will we skip a whole bunch of the install stuff then?
Yeah. You'll see everything. You'll see the same steps, the same sequences, all the same checks will still happen. But what will be abbreviated is, instead of reading the RPM payloads, that whole read section, instead we're going to get a small metadata write to create the inode for a file, and actually probably be, it could be dozens per payload, per RPM. And then there's a command. It's the reflink command is it's an IOCTL, an IO control command to the kernel that says, I'd like to make a clone range. So the command, this is all really nuts and bolts sort of stuff that happens very quickly, even though it's not quick to explain it. But the RPM header will know where all of the file extents are inside of the RPM. So it will be able to translate that into these clone range commands when creating the individual files. So that whole read and then write the file, the bulk of that IO just doesn't need to happen because it's already happened and we can just reflink copy them. So we get these really efficient reflink copies with ButterFS, and I assume so will be the case with XFS as well. So yeah, we could see as far as what the user will see, they'll see all the same text command line interface phases, and all those same checks will happen. The verification will happen. The cleanup step will happen. And those will probably be about the same speed. But what will be a lot faster will be the actual installation portion of it. Will be sped up by quite a lot. And the slower your storage, the faster the gain. So it'll be one of those cases where NVMe folks may not notice as much of a benefit as folks with SD cards and hard drives.
That is really cool. I have one more question, which is, do you know of other places that ButterFS is used? I know we mentioned OpenSUSE, which has a really good implementation of it. They're really killing it with ButterFS. But are there any other operating systems or distros where ButterFS is used?
Yeah, so OpenSUSE for sure is a significant user and contributor. Facebook, interestingly, is a significant user and contributor as well. They're not a distribution, but they do use it and they contribute significantly to it. And from what they've told me, they use pretty much every single feature in ButterFS in one form or another. One of the more obscure things that features in ButterFS is the seed device feature. And, unbeknownst to the ButterFS developers, even at Facebook, they didn't know that there was a portion of Facebook using this particular feature for their routers. They're using ButterFS seed read-only images to image some of their routers or switches or something like that in the networking stack that they have. And so folks interested in seed devices could go check that out. It's kind of an interesting feature. I've heard Synology is using it in some respects. They're kind of doing a hybrid LVM ButterFS approach, I believe. There's Rockstore also has a NAS type of solution using ButterFS. The Parrot project has been using ButterFS by default for some time. Also a little bit hidden, under the covers. If you're using Chromos, they support using native Linux applications, and the way that they do that via LXD, they've got this technology, the overarching technology, they call it, it's Crostini, and Crostini is using ButterFS behind the scenes for fast container creation, snapshots, and things like that. For supporting native Linux applications. So the Google folks are using bits and pieces of ButterFS here and there as well. So yeah, I mean, it's interesting. It is the momentum, I think, is picking up, which I think is a good thing for ButterFS.
That was a great answer. Honestly, that was a lot more than I expected. I didn't realize so many of these different groups and operating systems were using it. I thought it was more of a niche thing, but that's really awesome. That's all the questions I had written down. Do you have anything else you'd like to bring up? Anything ButterFS related, Fedora related?
I mentioned the shortcut tip in the chat, which is something that we don't get to talk about a whole lot because when doing examples of commands, we always use the full commands. And BTRFS is a little unique in that it has an optional shortcutting for commands. So as long as the command that you input is unambiguous, the BTRFS command will accept it. So BTRFS file system usage is the same thing as BTRFS FIUS. So you could also do BTRFS file usage or BTRFS, anything that, so long as it's unambiguous to the BTRFS command, it'll accept it. So what we've sort of started to see is that BTRFS users end up developing their own personal shorthand for BTRFS commands, which is kind of fun.
If you create your own, do you have to upstream them, or can you just put them in a config file somewhere?
You don't have to do anything. It's automatic. You don't have to. Yeah, it's and you can change. You can use you can use somebody else's shorthand. You can create your own. You can change your mind. As long as the command is unambiguous, it knows. It uses the one and only command that fits however you've decided to shortcut it. If you shortcut it too much and it's ambiguous, then it'll let you know. It'll let you know which of the possible options there are and why it's not accepting the command. So it'll be like, well, there's two possibilities here. Which one are you talking about?
That's really cool.
Yeah, it's worth it because it's worth looking into, because it is true that BTRFS file system du is quite a long command versus du. So the ability to shortcut BTRFS commands, the more familiar you get with it, I think is kind of a neat hidden feature, and it's not exactly easy to discuss because if I start writing guides that say BTRFS FIUS, people are going to go, well, that's encoded. I don't even know what that means. How is that? What does that mean? Yeah. So for the most part, examples are going to be use the full command structure, but users can shortcut that.
Honestly, I wouldn't mind if more shell programs would start adopting that. It's a really nice way to do it, where you can just start chopping off
Absolutely.
pieces. I personally use Fish, so it does a bit of that where I could just hit the forward key or the tab key, and it kind of does it for me. But, it's nice to have it in the program itself.
Right.
I think that is all. Thank you, Chris, for coming and letting us interview you about BTRFS.
Thank you, Grayson, and thank you, Edward.
Thanks for listening. That was Season 2, Episode 4 of the Fedora Podcast. Please visit podcast.fedoraproject.org to find our chat room, send us email, listen to other episodes, and more. We would like to invite you to give us any of and all ideas for future episode interviews and topics. Again, podcast.fedoraproject.org for email, forum, and chat room. Thank you. I'm your host, Edward. This episode was produced by Grayson, and technology made our music. This is the Fedora Podcast, a proud member of the Destination Linux Network. Please subscribe, and we'll see you in a couple of weeks.